to our channel. So for today, we're going to talk about comparing functions and what are the three main objective or subtopics for this comparing function.
Linear functions versus linear functions. Say or telling or identifying their similarities and differences. Linear and quadratic functions. Quadratic functions versus quadratic functions. For us to easily identify the differences or similarities of the given functions on a certain problem or scenario, we need to recall all concepts that we've learned about the key features of these two functions. Let me share you my screen.
So comparing functions, as I repeat the subtopics in here, we're going to compare two functions, linear versus linear functions, quadratic functions versus quadratic functions, and linear functions versus quadratic functions. For us to easily get the assessment or test, we're going to, especially during the major assessment, the given type of test mostly are multiple choice. If you know the key features of each function, we can easily identify the correct answer without solving it. Yeah, just analyzing the question, and then the options by using the elimination method, by eliminating the obvious incorrect answer and then just pick on those two closest options. That is the clue on how to get the answers if the given is multiple choice. Okay, comparing functions, again, we have forms of functions. Since we're comparing linear and quadratic, we will talk about the key features and recall the key features of linear and quadratic functions. For the terms that we need to remember, so let us recall the key features of the linear and quadratic functions. Under the key features, we can easily identify the difference between linear and quadratic first through its equation. By equation, the standard form of the linear equation is written in first degree only, in which it is written in a slope-intercept form, y equals mx plus b, where b is the y-intercept. Okay, where b is the y-intercept and m is the slope. Okay, there's no space at the bottom, so we'll just use the top. Okay, take note of that. The standard form is written in the slope-intercept form, where m is the slope and where y is the y-intercept. Next, for the quadratic, under quadratic equation, given an equation as standard form, we have three terms. The first one is what we call quadratic term, or the QT. And then we have also the linear term. Remember that quadratic function is written in a second degree. That's why you have an exponent of 2 in here. And then the last one, we have the constant term. Take note, constant term is also the y-intercept in quadratic. So if they're asking you what is a linear y-intercept on the given equation, quadratic equation, if whatever will be the value of your c, that will be the y-intercept. Okay, so that is how we identify the y-intercept in quadratic. Any question about that? Please type y if you have question, type n if you don't have question. Great, then let us have the graph comparing the two functions. Okay, for the linear function, the slope, if the slope is positive, if the value of the slope is positive, the graph is going up. Okay, so that means that this graph has a positive slope. Okay, for if the slope is negative, the m in here, if it is negative, the graph is going down. Those are the clues. Take note of those clues. Make sure also that you will write your notes, so that when you review before the CFA, you have your notes with you. And then for the quadratic function, the graph is, oh, by the way, let's go back. For the linear, the graph is a line graph, obviously, from the keyword linear, root word linear, line. In here, the quadratic function, for the quadratic function, the graph is what we call parabola. Parabola is the graph of a quadratic function. Okay, so we have, again, same in the linear. We have two kinds of graph. If the numerical coefficient of the quadratic term is less than 0 or greater than, I'm sorry, if it is greater than 0, or if the numerical coefficient is positive numbers, because positive numbers are greater than 0, the graph is a smiley face. If the numerical coefficient on the quadratic term is a negative number or less than 0, okay, the graph is a frown face or sad face. Take note of that. Those are the basic features that you need to remember. Okay, any question about the graphs? Then we'll proceed on the table. For the table of values, this is the most tricky for me because you need to analyze the output for you to identify if the given is linear or quadratic. Okay, of all three given forms of functions, okay, in equation, graph, and table, for me this is the most tricky one, but it is easily, if you know those concepts, like it is easily to identify if the given table of values is a linear equation based on the output or the function in here. Okay, check the input first. If the input are consecutive, like this one, they are consecutive numbers. Check the output. If they are adding and subtracting on the output, that means it is a linear function. Okay, take note on this one. 3 is increasing by 1, that makes it 4. So that means it is plus 1. 4 increasing by 1 to make it 5. So same as in here. So if you have a common difference or common multiple, common difference, that means this one has a difference of 1. That's why we're adding 1 from left to right. So that means this table of values is a linear function when you graph it. Okay? For quadratic, how can we identify if the table of values is quadratic? Since we have a parabola in here and parabola is a symmetrical figure, check the output. First, check the input if they are consecutive. 0, 1, 2, 3, 4. Those are consecutive numbers. Okay? In here, we have a symmetrical number. -1, -1. Then +5, +5. If we have a symmetrical output, that means we will have now a vertex. And vertex is the peak point. Is it the maximum or the minimum point? So this is what we call the vertex, the middle point or the peak point. Okay? So those are the concepts that you need to remember in comparing function for us to easily compare functions, whether they are linear versus linear functions, quadratic versus quadratic functions, or linear function versus quadratic functions. Okay? Any more questions? Again, so you need to remember those terms like x-intercepts. You need to learn how to identify the x-intercept, whether it is a linear or quadratic function. X-intercepts. In x-intercepts, your y is always equal to 0. That will be the value of your x. And remember that x-intercepts are also known as roots. Okay, we're using four terms in here, but they are just the same. These are also known as zeros. Take note of this one. And zeros are also what? Solutions. See, we use different terms, but we're just looking for just the same answer and one answer. This is what we call solutions also. So those are the terms. Another one is you need to remember what are slopes. Okay, what is y-intercept? On the linear, you have a slope. Okay. In quadratic, you have vertex. Y-intercepts. And we have also another term is the vertex. So you need to know how to find and what are these key terms for you to easily answer the questions on the topic that we have for this week. Okay, is there any more questions? Okay, so next, let's proceed on the next presentation. Comparing linear functions. 4 different linear functions are represented below. So we have 4 functions in here, and they are all linear functions. How can I identify the function 2 if it is a linear function? Look at the output, the y values, they are adding by 1. So that means it is a linear function. I will repeat, if it is adding and subtracting, it is linear function. If it is multiplying or dividing, it is exponential function. If it is symmetrical on the output, that means it is a quadratic function. That is how you identify the given table of values if what kind of function it is. Remember those concepts. I will repeat them, okay? If your output is adding and subtracting, it is linear function. If your output is multiplying and dividing, it is exponential function. If the output has a symmetrical output, like a while ago, it is a quadratic function. Next, let us have this one. So again, function 1, obviously, it is a linear function. Function 2, it is a linear function. Function 3, y equals mx plus b. It has a first degree given an equation, so it is a linear. And function 4, it is a sentence, okay, mathematical statement, slope and y-intercept. So therefore, it is also a linear function. Now, we're going to compare this 4 linear function based on the questions that we have on this side. Okay, so remember that the standard form is written in here where b is the y-intercept and m is the slope. And this is also the graph where b is the y-intercept. Y-intercept is the point that touched by your graph on the y-axis. And also the slope is the stiffness of a line. Okay, so let us have the first question. It says that which function has the lowest y-intercept? So let us analyze first the question before we start answering it. It is asking us about the y-intercept. For the y-intercept, okay, we're looking for the b because the y-intercept represented by a b, okay, variable b. And we're looking which between these 4 functions has the lowest y-intercept with it. Okay, first, can you identify what is the y-intercept on the graph? What is the point that touched by your graph on the y-axis? Please type your answer in the comment box. Okay. The question first is, what is the y-intercept on function 1? Function 1, good job. So the y-intercept is -2. Next, how about in function 2? What is the y-intercept? What is the y-intercept in function 2? Miss, is it easy to identify the y-intercept in function 2? Of course, yes. Okay. If the x is 0, if the value of the x is 0, the y-intercept is the value of your output. Okay, so the y-intercept is +5. Good job. Very good. So the y-intercept in function 2 is +5. Are you learning? Okay, next. What is the y-intercept in function 3? This one is very easy also. What is the y-intercept in function 3? Very good. So it is +1. So the y-intercept is 1. Next, obviously in here, so the y-intercept is -4. It is already given. So the y-intercept is -4. Then we're going to answer the question number 1. It says that which function has the lowest y-intercept now? Is it function 1, which is -2? Is it function 2, which is +5? Is it function 3, which is +1? Or is it function 4, which is -4? Perfect. Good job, guys. So the answer is function number 4. Okay? So we have function 4. Can you tap your shoulder and say to yourself, you're doing a great job? Okay, keep it up. So very good. So it is function 4. Can you follow? Let me know if you cannot follow so that we can go back and raise question, please. Okay, so we have function 4. Okay, next. Which function has y-intercept closest to 0? Which function has a y-intercept closest to 0? Is it function 1, which is -2? Is it function 2, which is 5? Is it function 3, which is 1? Or is it function 4, which is -4? Ta-da! Very good. So the answer is function 3. The third function, because the y-intercept is +1, and this is the closest value into 0. Okay, so the answer is function 3. Oh my God. I think you can get a perfect score on the CFA because you're doing great. Okay, function 3. Last question, last but not the least. Which function has the greatest slope? Miss, how can we identify the slope? Let us recall in here. Let me just use different marker so that you can see the difference between the y-intercept and the slope. To find the slope in here, given a graph, so we're looking for the rise over run. Change in y over change in x. Rise over run. Okay, so the rise is 1, 2, 3, 4. So we move 4 units up and then 1 unit to the right. So they are both positive. So the slope in here is 4 over 1. And 4 divided 1 is simply 4. So the slope in function 1 is 4. How about the slope in function 2? In here, given a points, we'll just use the formula of y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I told you, given a table of values, it is a long process, but it's just easy. Okay, so we'll choose 2 points. We can use this point and this point. Any point may do. Okay, but I prefer to use a lowest number and positive number. Okay, so this will be now the x sub 1. And this is the y sub 1. Y sub 1. And x sub 2. See, we have x sub 2 and then y sub 2. Then we're going to replace or substitute its value to the formula. The y sub 2 is 4 minus the y sub 1, which is 5, all over the x sub 2 is 1 minus the x sub 1, which is 0. Then we can simplify it. 4 minus 5 is -1 over 1. 1 minus 0 is 1. And -1 divided 1 will give us -1. So the slope in function 2 is -1. Next, what will be the slope in function 3? It is easily to identify the slope in function 3 since the given is a equation. Can you identify what is the slope in function 3? The slope is positive 2. Mx plus b, remember y equals mx plus b. B is the y-intercept and m is the slope. So in here, the slope in function 3 is 2. Next question, how about in function 4? Again, it is given. So the slope in function 4 is -3. Let me just draw a line in here because this one is different from that one. Okay, got it? So which function has the greatest slope? Is it function 1, which has a slope of 4? Is it function 2, which has a slope of -1? Or function 3, which has a slope of 2? Or the function 4, which has a slope of -3? Which function has the greatest slope? Perfect. So the answer is function 1 because function 1 has a slope of +4 because we're asking for the greatest slope, highest slope. So we have function 1. Perfect. Questions? So you need to recall also how to find the slope and the y-intercept given different representations like graph, table of values, equation, and a mathematical statement. Next, let us proceed on the next one. For the next one, we're going to find the vertex. Very easy and simple. So in here, Miss, in letter A, how can we identify what kind of function it is? So check the output. So I can see asymmetrical numbers in here, -3, -3, 0 and 0, and then +5 and +5. So therefore, what kind of function is this one? Is it linear or quadratic? Please type your answer in the chat box. The answer is quadratic function because we have symmetrical figures. Now, the vertex is the middle number or the midpoint or the peak point. So therefore, to answer this question, the vertex is 1, -4. That's it. See, it's just very easy, right? Okay, next. So for the letter B, C, and D, you will identify the vertex in each graph, and that will be your output for today. So very easy and simple. You will just identify the vertex in letter B, the vertex in letter C, and also the vertex in letter D. Any questions? Please add this practice one on your notes. Hope you've learned a lot for today's video about comparing function and identifying the vertex. So let us first have a review from yesterday from the part 1 discussion about comparing functions. We identified the vertex given a graph. For this one, we're going to compare two quadratic functions. Both of them are positive in terms of the numerical coefficient of the quadratic term since they are both smiley face. And now the question is, find the vertex and identify which has the lowest minimum. So we need to find first the vertex before we can identify the lowest minimum of the two graphs. So let's do this one. So on the first graph, the vertex, okay? So we're looking for the vertex. On the first graph, the vertex is, we read this one from x first before the y. Even in alphabet, x comes first before y. So we have -3, -2. So the vertex in here, we have -3 and -2. So that is the vertex. On the second one, on the second function, we have the given vertex. Let us use, okay, let us change this one. So that you can see the difference, we're going to use a different colored marker. There you go. So for the function, blue function, what is the vertex on the second one? So for the second one, x comes first. We have +1, -4. So the vertex is +1, -4. There you go. That is how we identify the vertex. Now it is asking us, we're going to identify which has, okay, which has the lowest minimum. So the lowest minimum, okay? So lowest minimum, in terms of the minimum, that means that is the lowest point, okay? Lowest point. This is the lowest point, okay? This is the minimum, and this is the minimum. Greatest minimum will be the blue one, okay? Lowest minimum will be the red one. So therefore, the lowest minimum is the graph 1. So the answer is graph 1. Because we are asking us about lowest minimum, which has the lowest, okay, lowest among the rest, among the minimum of, in terms of the vertex. So this one has a greatest minimum because the minimum of this one is greater than this one. Okay, so graph 1 has the lowest minimum. Don't get confused on that. Has the lowest minimum. There you go. That is how we answer it. In terms of greatest minimum or greater minimum, the answer is this one. But since we have has the lowest minimum. There you go. So that is how we've answered it. Any questions? If no questions, we'll proceed on the next presentation. It says in here, we're going to find the vertex from an equation. How to find the vertex from an equation? Okay, very easy. We already have a recorded video about how to find a vertex. We're going to use a Desmos graphing calculator. Then minimize this one. We will use Desmos graphing calculator to identify the vertex of each equation because it is easily to identify the vertex if we can visualize the graph. So to visualize the graph, we're going to use Desmos graphing calculator in here. Let me just move my face in here. So first we're going to graph the first equation, which is y is equal to 3x squared. 3x squared minus 6x plus 7. So this is the graph, the red one. Take note of that. This is the y-intercept. This is the vertex. The vertex is the peak point. Okay. So it is a smiley face because the numerical coefficient is positive 3. What do you think will be the graph of the number 2? Is it a sad face or smiley face? Great. It is a smiley face because the quadratic term is positive. So let us try to plug it in on the Desmos graphing calculator. Y is equal to x squared plus 6x minus 11. Okay. There you go. So that is the graph. Let us, there you go. Zoom it in. So this is the vertex of the red one, the first equation, and this is the vertex of the second equation. Now we're going to answer the question. The question is, which function has the greatest maximum value? Is it the equation 1 or the equation 2? What is your answer? So the vertex for the first one is positive 1 and 4. And then the vertex for the second equation, we have negative 3 and negative 20. So which function has the greatest maximum value? Uh-oh, look at this one. Both of the graph has a minimum value. So we're going to correct the question. The question was supposed to be which function has the greatest minimum. So we're going to erase this one and we'll change it into minimum since both graph, they doesn't have any maximum point because the graph, the opening of the graph are both upward. So it is infinite. So both graph have a infinite maximum, but both graph also have a minimum. Both of them have a minimum. So let us correct this question. It was supposed to be minimum, okay, minimum value. Which between the two graphs has the greatest minimum value? Is it the red function or the blue function? Very good. So the blue function, this one has the greatest minimum, greater minimum than the first function. So the answer is equation number 2 because the minimum of the equation number 2 is greater than the minimum of the equation number 1. Does it make sense? Hope you are learning. Then we'll proceed on the next slide if there's no question. For this one, you're going to check your understanding. So you are going to grab again the two function and please answer the following question. Which function or equation has the lowest maximum value? Are they both have the same maximum value? Yes or no? Which function or equation has the greatest minimum value? Does the graph has a greatest minimum value? think we already answered that one a while ago. It says greatest minimum value. So you already have your answer in question number 2. And for number 1, use this one. As I mentioned a while ago, both of them have an infinite maximum value. Next, for number 3, which between the two function or equation has the lowest minimum value? Try to answer number 1, 2, and 3. The instruction is graph the two equations or functions and answer the following questions. Please define your answer. Good job. So that's all for today. You just identify and compare the given functions, given an equation, graphs, and table of values. That's all for today. Hope you learn a lot in comparing functions, given both linear functions, both quadratic functions, or comparing linear function and quadratic functions. Hope you enjoy learning. See you again next video. Bye!